Hi, okay, so we're going to get started with the after lunch session. So I'm Justin Thaler. I'm from Georgetown University. We're starting with a really interesting panel on zero knowledge in the enterprise. So our moderator is John Rouach from QEDIT. So he's going to really be cracking the whip on this 45-minute, not 1 hour panel. And our panelists are Carlos Kuchkovsky from BBVA. We have Yael Kalai from Microsoft Research. David Archer unfortunately couldn't make it. But we have Mike Hearn from R3 and Jonathan Levi from HACERA. Okay, so you can take it away.
Thank you.
The panelists are going to use this.
Yeah, two microphones for the panelists. And we'll try to have a few minutes for Q&A. So if you think of questions that you have, feel free. So let's start maybe by introducing, each of us introduces himself. So I'll just say that I'm CEO of QEDIT, and again, very happy to have such an amazing panel. Go ahead.
My name is Jonathan Levi. I'm the CEO and founder of a company called HACERA. We are a small center for excellence in blockchain. We work on a few chains, public chains, private chains, worked a lot with Hyperledger Fabric and Ethereum, and we're just building a lot of solutions and develop the platforms themselves. Hi.
Hi, my name is Mike Hearn. I'm the lead platform engineer at R3, which builds one of the top 3 enterprise blockchain platforms in the world. I did the early design and coding, and these days we have a team of about 35 developers in London working on it.
Hi, it's working. Hi, I'm Yael Kalai, and I'm from Microsoft Research, and I'm an adjunct professor at MIT. And my work is mainly theoretical. I'm not building anything, but I'm hoping that you'll build our stuff.
I'm Carlos Kuchkovsky. I'm Chief R&D Officer and Technology Officer in New Digital Business Unit in BBVA. BBVA is an international bank. I also enjoy being board member in Hyperledger, Alaska, this is Spanish blockchain, Arinatba, a new international association. And I love combining crypto, AI, quantum computing to discover new amazing products.
Okay, so last year in our ZKProof, we were only 70 people, and now there's 150 people. So it looks like there's a little bit of a rise in this interest on privacy, on zero-knowledge proof as a solution for privacy. So maybe tell us a little bit, where does zero-knowledge proof meet you in your work, each of you? Who wants to start?
Well, the first time I discovered zero-knowledge proof, for me, was like some kind of magic. But when I started understanding that this is possible, we want to start using for data privacy, how we can start creating data ocean, and how we can start allowing people to share the data to apply AI in a more privacy way. And it's why we are super passionate about this. And now we think that it's possible, and it's why we want to start creating new businesses with this concept.
Yeah, so we don't traditionally think of banks as like the powerhouses of innovation.
Well, in this case, our chairman, that is an engineer and also studying in MIT, have a different vision of the finance industry. His vision and the vision that he put to all the organization is that we need to be a neutral advisor to recommend the best financial product and create prosperity. So for this, the data is super important. So the idea is how we can help the people to use this data to get better advisory for his life with privacy.
Okay, so around data for banks. You're researching these fields for a very long time. Have you seen a change recently or an uptake on the topics you cover?
Yes. So I've been studying zero-knowledge proof when I was a grad student, when I was a Shafi student at MIT. It was many years ago. Too many years ago. And, it's really an amazing and beautiful primitive that always was amazing to me. How come nobody's using it? It's so simple and so beautiful, and there's a need to it, but nevertheless, it wasn't used. And now, finally, it's wonderful to see that the world is kind of excited, and,
Well, what changed? What changed?
So what caused it, you're asking?
Yeah.
That's a good question. I'm not an expert to answer that question. It seems to me from my perspective, which may be completely false, is the blockchain helped a lot. All the, the cryptocurrencies are a big force in this. But again, I'm not an expert.
We actually have two people that come from connect to the cryptocurrency world. Do you think cryptocurrency has had something to do with zero-knowledge proofs?
Yeah, so I think the biggest thing, so I also studied it very early. I'm older than I look. I probably look older than I feel, actually. But I studied zero-knowledge proofs from Oded Goldrich and Weizmann, and when we didn't even have the book, we had like kind of manuscripts. And at the time, it was like, look, the proofs are long, it's difficult to compute, we're not sure, but it actually gives you like zero knowledge, kind of you have to convince somebody without like letting him do something that he couldn't do before. And it was a very nice framework because you really don't reveal anything. So theoretically, it was fantastic. Physically, what happened is you need to have all the burden on the honest prover. So we needed to find a usage where it actually takes a long time to produce a proof and then very easy to verify. And anything that has to do with consensus is basically when we have like easy verification process so that the miners can make some money while not computing that much. And the honest prover can actually use the proof itself to keep the privacy, then there is some value there. So that actually helped a lot. And the Zcash Foundation and a lot of research there, it actually made the Zk snarks feasible. That helped a lot. So now it's very easy to take a library and start using it.
Right.
Yeah, so.
But I want, sorry. True, but still, I mean, it's not like before people came to us and told us, oh, we would love to use ZK proofs, but unfortunately, the runtime of the prover is too long. Can you make it shorter? It seemed like, okay, they were invented. We thought they were amazing, but nobody else cared. So, and now, finally, people come and say, okay, and I think that's why there's been so much amazing work in the last 2 years because of this pull.
So maybe what is that problem in blockchain that zero-knowledge proof is so well solving? Mike, do you have a...
Yeah, sure. This is actually one of the hardest questions to answer because the holy grail, of course, is that you replace all the transactions just with recursively composed proofs. And then you don't see people's transaction histories anymore in any situation, and that's what everybody wants. That's very hard. So to really apply these technologies anytime soon, you need more ad hoc sort of, I hide this field in this way and that field in that way kind of techniques. And that's also a difficult engineering problem, but we can discuss that if you want.
Originally, when the first cryptocurrency started, people looked at privacy and said, so that's Bitcoin, and said, well, we can do pseudonymity, and that will solve all the problems. What's your take on that? And maybe connected to why couldn't banks use such a technology?
Yeah, well, Satoshi wasn't a cryptographer. We should remember that, right? Like there was very clear signs in the design that he didn't really have a cryptography background. And you were saying, why did nobody care? Well, no one really knew about it, the fact that you could actually do general zero-knowledge proofs. And I remember I was at a conference in 2012. It was a very early Bitcoin conference, and Eli Ben-Sasson came and gave a talk.
Sam Jose, right?
No, this one was in London, I think.
Okay.
I'm thinking of the one in London. And he got up and he gave a talk where he said you can actually take any arbitrary program or any pure function and prove it under zero knowledge. And everyone walked out of that talk being like, mind blown, I must learn more. But of course, all these papers are very hard. And we asked him at the end of the talk, there was a Q&A, and we said, how does it work? And he said, that's like an entire grad student maths course to teach you that, so I can't answer that question today. And that's where it started. And from that point on, people have been learning and reading, and that cryptocurrency community started to meet the cryptography community in a more formal way.
Maybe a follow-up on that. How can you adopt a technology that you don't understand? How do you even approach setting up processes to analyze what is zero-knowledge proof, how you take it into your systems?
Well, thanks God, I have really good cryptographers in the team that I trusted on them. But the idea is to understand where the impact could be. If the impact is far away from 5 years, we stop our research. But if the impact is before 5 years, we start analyzing what are the main business or use cases that we could create or could create efficiencies. So when the people talk about zero-knowledge proof for blockchain, on-chain, decentralized network is great. And I think that could improve a lot of trust, how the people exchange, but also you can combine with federated and also with what we call, or other people call cryptotech, is using zero-knowledge proof without blockchain. Imagine what happens if you start using zero-knowledge proof with APIs. The people trust in APIs. The people trust now in current internet. So there is an opportunity to combine these three areas. And it's where we are now putting the focus.
So I can tell you, like, we have a few systems in production, and we're using zero-knowledge proofs in sometimes not intuitive ways. Like, we use it for privacy, of course. We're using identity mixer and some other technologies that are actually proven. We're using zero-knowledge proofs actually for verifications. So I'm just gonna like do something, calculate something off-chain, and then like basically vote on-chain for the verification of it, and scaling. Like, people overthink about zero-knowledge. Oh yeah, I can hide some stuff, but you can actually scale. So if you look at like stocks, is basically people are trying to use it now for having like a lot of transactions together, and then basically just to sign on the order. So we can use zero-knowledge in different ways. We play in the fields that we are like kind of more active is like trade finance, which is not like always asset transfer. It can be like micro lending. It can be like your credit score and things like that, that I can just need to prove stuff without like giving you the actual balance or the actual transaction information. Supply chain has a lot of issues with validating who is the supplier, what am I trusting, I don't know, latency times, approving that, or confirming that something was received on time and stuff like that. And scalability in terms of I don't need to validate every transaction on every block, and then it takes me so long to synchronize. So yeah, there are many usages for.
So Mike, in R3, you took a different approach, right, to privacy. So maybe to spice things up, this is, why not use SGX? This is a perfect solution. SGX by Intel, trusted execution. This is a bet that you took on a technology that maybe solves the problem of privacy for blockchain, and maybe at scale. Why not use that?
Jonathan told me to be as controversial as possible on this panel. Why did we not go for zero-knowledge proofs? That was my call, so you can argue with me about it. We don't see these things as solutions exactly. There are different trade-offs that suck in different ways, and then we have to explain to people, how they don't work in various ways and how they're going to be disappointed. 3.5 years ago, when I started designing Corda, I had to make that decision pretty quick. And at the time, it was clear whatever we picked, it would take many years to really reach production and encrypt or hide the entire ledger. And at the time, with SGX, it's got its downsides, but the advantage for us right now is, we can hire anyone who knows embedded programming and get them working on it. The performance is about, at worst, half of what a regular core will do. And we wanted the ability to take existing apps that have been developed in the intervening years when there was no such privacy tech and just keep them working. Now, we have actually fairly detailed plans on how we will eventually migrate to zero-knowledge proofs in the long run, away from SGX, at least for some use cases. Some things you can't replace. But for the ones we can, we have a fairly long-term, very long-term roadmap where we go to SGX and then we go to zero-knowledge proofs. But it was not possible to go straight there right from day one.
So you took this decision two years ago, right? When
About 3.5. Yeah.
3.5. Would you consider that there's been progress in the space that allows a different angle on that?
Well, I would still make the same decision today if I had to make it today, but the progress is very clear. Things are clearly heading in the right direction. And this is why I'm here, and this is why Kostas was here last year, and in fact is here again today, although he no longer works for R3. But we're keeping an eye on things very closely so we can make sure that we stay up to date with this technology. Things like the updatable SRS talk from yesterday. This would be very important, for example, to deploy for real. Recursively composed proofs, that's very important. The DISC talk yesterday was very interesting to me because the circuit sizes we would see with the business logic for the apps that are being written would be in the billions of gates. So that's another problem that's falling now to the fundamental research. Once all of these fundamental problems are solved, then we've got maybe 10 years of work to get it into production in live networks. So we need to be realistic about the timelines here.
Okay, controversy, so that's easy. So SGX is already using zero-knowledge, right, for 10 years. So you already have, like, the remote attestation in SGX already works in a way that I'm actually securing an enclave, and when I set it up, I just want to make sure that it's secure, and that my, let's say, CPU or the part of that CPU that was produced, let's say, by Intel, it can be also with AMD, by the way, is not revoked yet. So that part of being able to not revoke something anonymously is done already with zero knowledge, and it's actually relatively old technology. Like, actually, maybe old technology is not the right thing to say. It's actually proven. Like, we do see some stuff from time to time with SGX, and we have a lot of stuff with like side channels, and like we have some issues with the way we compute stuff in general, and that's like a more generic, or let's say kind of much more kind of a lot of issues with trusted execution environment, more than just the Intel CPU or the SGX implementation itself. We also partnered with Intel early on. We also work with some secure enclaves. But I think that what's more interesting is actually to try to do stuff like now. So we're deploying stuff like today. And we cannot use everything today, but just one example, because we talked about disk, right? So if you look at like the way Howard Wu implemented it, they write that basically there's a lot of stuff that they wanted to take from libsnark, which is written in C. And because they're trying to use Spark and they're trying to use a lot of kind of infrastructure to decentralize stuff, and it was very easy to decentralize with Java, it was easier for them to not use the C++ to Java bridge. So that's like very interesting, like right now, to take libsnark with a better kind of scheduling mechanism and to apply it today. And of course, it will take time, and you need to secure stuff. Look how many kind of revisions we had to OpenSSL. So software always has issues, and hardware always has issues. But I think it's really important to try to push the market as much as we can today with what we already know. There will be room for like what will happen in 10 years, but it's really important to be practical. Otherwise, we're going to lose the momentum. That's what we see.
Being controversial, as I was saying, I love the vision of on-chain with the real world, the physical world. When we started analyzing the trusted environment, trusted execution environment was for a project analyzing the insurance with the connected cars, and also with drones. We want to know that these data are from these devices. So for this, you need some kind of trusted execution environment. The second part is, I don't want to revelate the data, but I want to be sure that the data comes from his device and this user. So the combination of trusted environment with third proof for me has a lot of opportunities in insurance. How you can also connect this with smart contracts to start creating a better insurance.
So at the source of the data, make sure that the data comes from the right devices.
The second part is the privacy part. You need to demonstrate that the source is from this device, but you don't want to demonstrate. Imagine that you are putting sensors in some kind of infrastructure and that where you spend out of money. You don't want to revelate all the information, but you need to...
In a way, this could combine, the technologies of trusted execution could combine with further technologies based on zero knowledge that process the data.
And the second part is multi-party computation. If you want to start applying federated learning, or you want to apply AI over distributed and encrypted data, you also need these three technologies. And of course, with on-chain or with blockchain, but it's better with blockchain.
So Yael, when we talk about these technologies, it seems like there's many different libraries and a lot of activity in research that's happening. How do you pick what topic you focus on? How do you prioritize which kind of research to do? Is it somebody knocking on your door and saying, well, I have this need, please solve it for me, or?
Yeah, so nobody's knocking on my door, but I definitely, and my research is, again, I'm kind of a theoretician, but I'm definitely, me and all of us, I think, the theoreticians here in the group, are motivated by this, how, definitely the way the world is shifting is inspiring my research as well. What questions we study are definitely motivated but by what we think are the world, what the world needs. Just as an example, until a few years ago, most of my work was, I was kind of working on trying to get, my work was on private verifiable zero knowledge proofs, succinct proofs, and after kind of seeing that, wow, people are really interested in public verifiable things that can be verified on the chain publicly by everyone, that definitely motivated my research.
So the type of research that you're doing and the onus that's on your shoulders to, or on theorists in general to prove the security of what they're doing, the three of us are Israelis. We just experienced very high-tech technology crashing on the moon instead of landing on it. We would not want, the assets moving around the world using technology that's not solidly proven and extremely secure to a point where you can avoid those kind of problems on critical systems. So what do you think is needed to move this field to a place where people trust the technology to a point of replacing critical systems with such advanced cryptography?
Okay. So I think actually the bottleneck is not, I think what we provide, whether we base it on assumptions that we really believe are sound, such as discrete log or lattice-based, or whether we base it on things that are more heuristic in nature, such as knowledge of exponent assumption or these more kind of shady assumptions, I don't think that's the bottleneck. I don't think anybody's worried, actually, that in real world, people will break the more shady assumptions. I think coming up with schemes that are based on solid assumptions is very important. That's kind of what really drives my research. But for practical use today, I think the main problem is actually not that our schemes, as we propose them theoretically, are insecure, but that they're implemented in an insecure way. And that's a problem not with this advanced thing. It's a problem with the way RSA is implemented, the way all the basic crypto primitives. I mean, we hear every time we hear of attacks. Nobody breaks our security proofs. The attacks are in the implementation. They use bad randomness. The keys are somehow stored in unsecure places, or So I don't think it's actually the assumptions that are problematic.
So in that sense, if you go back to this discussion of public blockchain versus private blockchain and how this field moved from an acceleration from cryptocurrencies, in a way, cryptocurrencies today serve as a big sandbox to test these technologies and test implementations, so that under a big lab, that those core technologies are sound. Do you guys look at, in what you sell or what you implement, do you look at cryptocurrency as an inspiration or a place to test technologies, or how do you approach the advances in cryptocurrencies?
Yeah, Corda so that's the name of the platform that we've built, is very Bitcoin inspired, more than Ethereum, I would say. And yeah, we do look at some of the things that are happening in these communities, but the sense I get actually is that the so-called private blockchain space is not actually quite as simple as public versus private, is investing more heavily in research at this point, is moving faster, and the interesting new technologies are appearing there first because they have the funding and can focus on that. But
there seems to be a lot of funding in public blockchain as well. I think there's a few people here that can.
There's a lot of money sloshing around, right? There's a slight difference between money and funding, in my view, because a lot of it doesn't really get directed towards long-term research. So, the sense I get is that over time, the so-called private blockchains are actually going to become much more public. Right, all the people building these platforms want them to be widely adopted for business reasons. It makes sense. So the only reason they're somewhat restrained today, or the primary reason, is that simplifies things a lot. You can invest differently on attack versus defense versus features if you know who's going to take part. But eventually, we want it to be fully or nearly fully public, so anyone can take part, and the distinction will disappear.
So I can say practically that we have our own zero-knowledge implementation, like the non-identity mixer one, and we took the entire trusted setup from Zcash. Sorry, but thank you. And no, because people spent so much time criticizing it, and we talked about it like last year, actually, and we were just thinking, like, we cannot come up with something that was tested as much as that one, and even if we come up with something new, well, like not that big. We cannot push it like onto the main Fabric kind of code base. We couldn't push it on top of Ethereum because of the account versus UTXO kind of thing that Aztec is working on now. So there's stuff that we kind of do the best we can, and we're looking to see if there's any other criticism. But it's very true. Like, most of the hacks, and I used to work in cybersecurity actually kind of on more the offensive side, and you always exploit something which is either an employee from within the organization. It doesn't matter. They logged in, and then you just like let them download something, and then you just have fun with whatever you need. Or people just don't implement stuff well. And I worked many years ago, like, Rene was here, and when I listened to what he was talking about, like having the hub and the habit to see everything, really, our blood, like in the back there, was really boiling, because, like, it's really disheartening to see that after so many years of research, publication, so many libraries that are already available, like some of the decision makers are still kind of not open to try stuff. And on that front, I know that like using cutting edge technology is risky, and I understand the fear, and it has ramifications, etc. But I'm also saying that if we're not going to bring in new blood of kind of research and some new spices, kind of, usually I say it like, you follow the same recipe, you'll always get the same soup. So we need to like try something new in order to kind of break conventions and to understand that, yeah, we can always use pigeons to send message, but we can also like try to use some new technology. So on that front, I would say that I worked on, I don't know, I certified some AES implementation for Cisco systems like many years ago. It was FIBS 140-2. And they were very anal about like zeroizing buffers, and every pointer had to be like nullified before you call and after you call. And it was really helpful because we had to rewrite the entire thing, to be honest, until we got it approved. And only then the NSA approved that router that worked with Wi-Fi and some TLS implementation to be used in the US in some military kind of thing. But we had to go through the entire spec and change almost every single line of the code in order to get certified. So we need more processes.
This is interesting. The amount of work that went into this public spec of Zcash is insane.
It's insane. Yeah.
The level of quality that was put.
Yeah.
And that's something that you wouldn't expect from a project that could probably make a ton of money without that level of excellence. And then that sets the bar for what is a spec in this realm of applied zero-knowledge proof. Do you think that the industry should strive to prove the protocols that are being deployed in these distributed settings?
I think attacks are a function of the value of the traded kind of network. The more value you have, it's like a honeypot, right? And then more people are going to attack it. If there's no value, they're less likely. Maybe they'll do it for fame, where we have like some, quants usually have like this machine learning kind of competitions and AI and stuff. So we can try to run stuff like that. But once you have like real value and you let people like attack it, and if you know that it was not stolen, that's the best test, I guess. And I can tell you about some tricks that we used to do when we were like, I don't know, younger maybe. So we used to have like some credit card. It's like a nice thing to do, like as a honeypot. You just have some credit cards in your system that don't have a lot of money. They have like $100, let's say, limit. And you just leave them in the system. And you have a notification system that the minute one of these cards were used, you know that somebody hacked into your system. So if you have like early notifications, it's very easy for you to detect stuff. Because the problem that we saw in Zcash, and kudos to the guys that actually fixed it, like, I'm going to say something like, it's a bit controversial, but we don't know if one of the guys from the Zcash Foundation did not print kind of $10 million and kept it before you guys patched it. And we trust the people because we know you guys, but this is where it's becoming like very dangerous, right? You have like a very kind of opaque system where we couldn't know that there was an issue at all, and we need to trust the foundation. And I'm just going to talk a little bit more about such a model. People are talking about like, I want to have like a censorship-resistant system or a computer that cannot be stopped, and I want to have like a smart contract that nobody will be able to kind of make not to run. I think that this is like dangerous. Like the robots are coming, right? So we shouldn't have like these systems that we cannot break at all. It's always nice to have some notion of an auditor or some notion of being able to have some system. So we built a system that was presented in RSA Security, actually, and we didn't make a lot of noise about it, but it's going to be like pretty big. It was an infrastructure project where people actually needed to vote on any changes to the infrastructure. So in order for you to run a Docker kind of container and to run anything or execute it there, you needed to have a vote. And then we really applied like really strong crypto, like threshold signatures, and have a voting mechanism just so that we have like the nuclear button so that we can stop the system at some point. But we need to have the auditing and the actual governance there. So I don't believe in like going like all in cryptography, like we cannot stop and we cannot change anything. I think we need to find the right balance because we make mistakes.
At some point, there was this exact controversy in the Bitcoin world, right? If we should, as a Bitcoin community, have an opening to regulators, to police enforcement, or should we move to more and more privacy without any possible recourse, or should we leave a space for for agencies to come in? Did your point of view change since a few years back? Do you have it ready in the systems today in R3 for regulators to be able to stop processes and have override?
We don't, but the system is still being built, and some of this is pushed up to the app level. So people who build apps on the platform can decide what kind of controls they want there. The point you were making about the difficulty of knowing if it breaks what happened is one we're very sensitive to, and the way we have two different designs for how to use SGX. And in one of them, if it breaks, you lose ledger integrity, like with Zcash, right? And in the other one, it degrades back to the current privacy level it has today. And that's actually more complicated to implement. But if anything, it's actually an easier sell to have a system. You say, well, maybe it's like 80% as strong. Maybe it's going to break more frequently. But when it does, you just get what you've got today. You don't lose everything. Now, then you enter the question of like, how do you evolve it? How do you change it? We've actually set up a non-profit foundation in the Netherlands with a board of directors elected from the user base to solve these kinds of questions. And so actually, it won't be up to me. It won't even be up to R3. If we eventually end up with enclaves that give backdoors to various agencies and so on, that will be a vote of the user base, which is international, by the way. We've set it up so there's geographical diversity, jurisdictional diversity to try and ensure this works out well.
You go back then to a sort of model of governance for these distributed systems where even in order to detect that there's a problem in private transactions, you still need some form of central governance to override the problems. So in the end, you end up creating systems that have a sort of central place where you can get a recourse to problems that arise between parties.
Well, not necessarily. For privacy, you can set whatever policies you want with techniques like SGX or zero-knowledge proofs. You can put a backdoor in if you want. And the question is, should there be one? Who gets one if there should be one, and so on? And that decision is being delegated to the user base because, who's to say we're right?
So then a regulator could say, you've now created a system where policy can be chosen that nothing is revealed and transactions are completely private without the possibility of oversight. And this is in a way it's a very strong weapon in the wrong hands. So maybe how do you give tools to regulators to still accept such a freedom of transaction without possibility of oversight?
Well, you start by talking to them. So we do. And R3 actually has lots of contacts with regulators. It's also important to understand their goals, right? It's very easy for engineers and so on and cryptographers to think in terms of what you could do with the mathematics and to get distracted by that. Like there's a discussion running at the moment, it's an open source project, by the way. The open source mailing list where they say there are keys in this system, therefore there must be key revocation, right? And then people say, well, what does it mean to revoke a key that's on a distributed ledger? It doesn't really mean anything. And people pop up and say, well, it should mean that the funds are seized or that you can't trade anymore with these funds. And people start working backwards from this cryptographic protocol construct to let's sort of jam it into some imagined, often regulatory requirement. So what you go is you go to them and say, what are they really trying to accomplish? They don't want people to be kidnapped. They don't want ransom. They want like some controls over drug dealing and stuff like that. And so you say, well, what do they all agree on versus what does one country want, and you can set things up such that with threshold cryptography and votes on what enclaves are allowed and all these kind of things, you can set it up so that only the really globally acceptable policies get implemented. I think that's the best you can do. If everyone agrees, if every government agrees, you've got to not do that, then there's nowhere to go.
Thank you. If you have also comments, meanwhile, if you want questions from the audience, so.
One of the things that you were saying before is what do we need to make so this could scale and be used. The main part for me is regulation and supervisors. There is really good thing that we can make is start evangelizing and educating, because the regulator, if they don't understand, it's impossible for them to accept. So they need to start understanding this, and for this they need to start reading from easy things to complex things. This is one part. The other part for me is it's important to project what is going to happen now in 3, 5, 10 years, because now the people is using zero knowledge proof and other things, cryptocurrency, for speculation or trying to start using for payments. But when you connect with real world, when the people not only buy some kind of debt, they buy real things, they could use cryptocurrency. And for this, we need to connect with mobile phones, we need to connect with cars, we need to connect with other things. So it's important to start projecting how we are going to use these new superpowers, the privacy with verification, for real things, not only for speculation and the new decentralized finance that is amazing and I love, but one more time, it's important to project.
Thank you. So to the audience.
Yeah, audience questions.
Hello. I have one comment regarding bridging theory and implementation. So one comment I think by Yael was that a lot of times systems are not broken by breaking the mathematical assumptions, but because the implementation was not good. But one possible perspective in some cases is that actually there are not enough assumptions. So for example, a scheme is broken because there was a timing attack and the modeling of the system did not take into account that time is a factor. So I think that's an important factor to take in consideration.
Yes, so you're right. Actually, I think one of the most interesting questions for me, for us, for the theory folks, is to model get a more realistic threat model. So for example, talking about timing attacks, there's been a lot of work by a bunch of people here in this room and trying to get schemes that remain secure even if there are timing attacks. Encryption schemes, signature schemes, and there's a lot of very beautiful work out there that take that into account. There's also, so I would love, I think that's a great question. How do we change the model so that to offer you guys more, right? So now we're saying, look, as long as you satisfy our ideal constraints, then you're secure. But these ideal concerns are never satisfied. So, okay, fine. So now you tell me, look, my keys are a little bit leaked. Okay, I'll help you with that. I'll give you crypto that even if you're leaked, it will be okay. What else? The problem that I hear is happening, and again, I'm a theorist, it's not my expertise, but that the way that things are implemented are wrong. There's just bugs in the code. And actually, I think that's a fascinating question. How can we help? So it's really to the point because I'm thinking about this question a lot. So one question I know that's happening, people complain, we're using bad random. In real world, we assume there's perfect randomness. In real world, there's not. And there have been so many attacks. There's now even on Bitcoin, right? The signatures were attacked. And I don't know if it was a large-scale problem, but, at least there's attacks all the time using bad randomness. And there is actually, that's a great question. And I think there's a lot of literature on this, again, that a lot of us have been involved in, which is, okay, let us try to help you, even if you have poor sorts of randomness. So we are really making an effort to bridge the gap that you're mentioning. I think one of the most interesting questions that I would love to understand, and I'm kind of boggling with, is how can we offer you crypto that even if you have bugs, somehow it will still be okay. You won't be completely compromised. But I think kind of this bridging this gap is a fascinating question, and I just want to tell you we're on it. We're trying, but it's not even clear how to define, how to capture the question there.
Yeah, I would actually just say that I as an implementer do care about the underlying assumptions, by the way, and one of the difficulties that I find in this space when I read papers I don't have a cryptography background. I haven't studied, I haven't done a PhD in cryptography. It's often very unclear when reading these papers what assumptions are being made and how strong they really are and whether I should care about them or not. If I read a paper and it says that it's been aggressively proved in the generic group model, I'm like, wow, it's been aggressively proved. It doesn't get better than an aggressive mathematical proof, right? And then, of course, when you find out what this really means, you think, right, I don't really know enough to really judge. Is this problem hard or not? Is it trustworthy? I really love papers where they say we've reduced our assumptions down to, discrete log and random oracle, because I'm like, well, I use SHA-2 every time I connect to Amazon.com. That's good enough for me. And then if they say that's all it is, then I'm happy. Whereas if it's more complex, then I don't know whether it's even worth worrying about this or whether the maths will be replaced next year. So I would say that the assumptions do matter. And when you remove these exotic assumptions, corporates do notice, and we do care. Yeah.
So just quickly on that. So it's not only the implementation. So we audit a lot of systems as well that people design stuff. So we designed back in the day, 3 years ago, a certificate system that was standard. So when you want to join a network, you basically in a permission network, you get an X509 v3 certificate. And many design assumptions. Okay, let's talk about zero knowledge. It's a good example. They make it people design the system thinking that now that you have proven to me that you're over 21, I will let you in. It's not enough. Sometimes it's necessary but not sufficient. And people just assume, oh, but I have a certificate. So think about real world assumptions, right? You go to a bar, you show that you are over 21, but the bar is full. The fact that you have a certificate doesn't mean that you are granted the absolute right to do whatever you want in the system. And many systems integrators or designers don't use even the well-implemented technology correctly. They just don't use it well. So I think we need more of the theoretical people involved in the process and to audit stuff. And we are trying to actually, HACERA at least has a few very big shots advisors helping us all the time. And we make mistakes because we sometimes get so much into the use case. And you guys, I don't want to name people that don't want to be named, but no, it's really helpful to get Jonathan, are you making assumptions about the attacker again? I said, no, it's not me. Okay, let's just, let's just try again. So it's very important to get some sanity checks from other people and to review stuff. This is why I really like the open source model, that we can attack stuff and break stuff and get famous if we do. So there's some bounty associated with stuff. Because if you do stuff if we're gonna go back to the dark ages of security by obfuscation, and I think we're past that, right? So people have to remember, protocols are actually open, and they are not the secret. Your private keys, your signing keys are the secrets. And the more we open up the systems and the designs to public scrutiny, I think the better. Yeah. So.
One more question?
It's more of a comment about the governance model. If you remember, the US Constitution allows for amendments with 60% of the House voting for it. It's a kind of a threshold cryptography. But you see how broken it is. I don't think you're going to see a new amendment in our lifetimes. Similarly, if you set up these systems with this kind of governance model, I think you guys are going to see emergent effects where everything comes to a stasis and no decision ever gets made because of these kind of things between the enterprises that are deciding to vote on these systems.
So, okay. Oh, actually, I have a mic. So when we look at companies, enterprises that are building consortia and deploying these private blockchains, the hardest problem is not the tech, is not the all of this, is actually what you described, which is how do we trust each other to build this new NewCo that's going to govern this network, and what will be the governance model. They spend a year, 2 years just fighting on who's going to have the right to overrule who, and they're all big companies that so the whole problems get projected into articles of association of poor companies that are originally meant to to be operating some network, but in the end become what you're describing, these constitutions of a larger network.
We have time for one last question, I think.
So my question is for everyone in the panel. What do you think is the most important thing, that there is a delay on applying all of this technology in real financial transactions, apart from blockchains, because it's not only blockchains? So there are a couple of issues mentioned, like even standardization. It might play a role because it goes in contrast with threat models in some companies, that they have to comply with regulation and other stuff. Other things might be how to store secrets, I mean, private witnesses in zero-knowledge proofs, because banks have to store somewhere their secret keys. And at the moment, we don't have an HSM or a Trezor or something that can actually store Z addresses or something else that we use for signing transactions. Is it the complexity? Is it, for example, that we find attacks every few years, either in some elliptic curves or something that decreases the security advertised? Or what do you think is the main factors that delay all of this approval from the community and then application for business products, not just experimenting with zero-knowledge proofs?
All of the above. The theoretical issues I worry about less, because you guys are making such good progress, and every year another problem falls to a great paper. There are the main issue that I see that is not really making much progress at the moment is, for us to deploy it, our customers are just ordinary business developers. They're domain experts in insurance or whatever, but they're not expert programmers. We need them to be able to just use their existing Java skills, for example. And so one of the things we've looked at, or I've looked at least, is what would it take to compile arbitrary Java bytecode to zero-knowledge proof, right, via constraints. And the tech is there. You can get compilers that expand, recursively inline everything, partially evaluate everything, eliminate all the heap allocations, lower it all to SSA form, and then you can sort of squint a bit and see maybe you can go to constraints from there. But no one really seems to be working on that much. And then, even when we had all that tech...
Is that a call?
That's a call. I would love to see a paper like that. That would be really interesting to play about with.
To solve your Java problem?
Well, so we're going to have a migration issue, right? The thing is that we're not going to reset the system when this technology finally matures. So we're going to have to find a way to incrementally deploy zero-knowledge proofs into a system with many, many nodes and many apps and many developers who know nothing about cryptography. So anything that can make the tech more approachable to ordinary developers, not having to learn DSLs and things, that's like a big area of work, which would be great to see. The other things I think we'll find solutions for over the coming years, but yeah, there's a lot of work needing to be done.
I can tell you what works on our side. Like, actually, instead of telling what's not working, is there is no standards, and that's kind of one of the good reasons to be here. So even in layer 1, everybody's fighting over layer 1, and I think it's a ridiculous fight. Like, Ethereum has issues, Hyperledger Fabric has issues, Coda has issues, we have to admit. And there are also, actually Coda is perfect sometimes. Coda 4 at least, So, but what we did well, actually, we tried to kind of abstract that layer completely, because we realized that, these big guys are going to continue fighting, and we don't have time for this. We have to really look at the value proposition. So if layer 1 is going to be like Ethereum Fabric, Coda, and layer 2 is going to be like the side channels, payments, Lightning, or however you want to kind of model it, it's very important to actually look at the value of why we're trying to have a consortium. Because whenever you have, especially in enterprise, right? Whenever you have like a sector-based consortium, what happens is actually these guys are usually competitors. They are not friends. So this whole model of the miners are your friends, it doesn't apply at all. And the issue that we had is that everybody was so busy with the layer 1, how many TPSs, do we trust that signature, etc. Is it RIPE MD 160? I don't think it matters. What we did well is actually created like an abstraction layer that allows, like the unbounded network today allows you to deploy a smart contract and data on Fabric, Ethereum, Coda, even like a payment with Green. So we don't care about that much. I think what we used to do wrong, we used to believe the people that came to us with the problem, and we used to believe that they understand the problem. And it took us a long time to realize. So I'll give you like a practical example. We're working with hospitals. And we thought, and it is a very similar thing that what René from NIST was describing, we thought that if we have if you remove the PII, if we have an anonymization process where we have a lot of trial data, and then we remove my home address, my age, my blood type, then we can all share data. And it's trial data, it's important, it's going to save lives. And we were always trying to design it in such a way that you will not be able to infer or correlate the data to people. And it was only once that some consultant actually told me, he said, look, when you guys are sitting around the table, you always say patient data, patient data, patient data. I think that's the problem. You have to understand, for these hospitals, this is customer data. They don't want to share how many customers are coming in every day. They relate it, what you offer them in terms of how much money they will get from sharing this data to trials. It's a lot less than the risk of giving you some business information about each other. So what does work is actually, you have a consortium, you have to really see into the value so that you can have the disruption. Otherwise, they are not going to change anything. So insurance is a good example. We were working with a consortium with one of the very big providers.
I'm getting a sign.
Done? Okay, so I can talk about it one day.
But I can thank you and all of you for this panel. Thank you very much. Thank you.